Hey everyone, I'm going to explain how I solved problem 3 and problem 4 in lab 4. Problem 3 wants us to rotate the picture 90 degrees to the left, pretty simple, and problem 4 wants us to shrink an image so it's half as big as the original. Pretty straightforward. It says to use the third argument in the range function to help with this problem, so that's what we'll do. How I solved problem 3 is I just drew a picture, simple picture, ABC, couple letters, and I drew the translations of where I wanted them to be, and so I just gridded them out. Used a 3x3 pixel simple image, and you'll notice that when you translate A and E and H, as that's how we'll iterate through this image, is we'll hold X constant and we'll go down the Y, so we're down that column. We'll notice that it goes from 0, 0, the original, to 0, 2, and 0, 1 to 1, 2, 0, 2, 2, 2. We'll notice that this column is held constant, so we'll know that we'll want to put the width as this Y value. I'll show you in a second in the code. And actually, I'll just show you real quick right now. It'll be easier to demonstrate. So to rotate the image, we'll start by defining it. We'll pass it in an image. We'll find the height and width of that image. We'll create a new picture with the inverse of those dimensions. So width and the height, then height and width, switch them up. Then we'll iterate through the original image. So X for width, Y for height. As we iterate through, we'll go 0, and we'll go through all the Y's. Then we'll go X will be 1, then we'll go through all the Y's again, so on and so forth. And each time as we're iterating through, at each iteration, we will want to set the color of the new picture, or of the pixel of the new picture, from the color of the pixel of the original image, and again at that current iteration. And the translations for the new image, as I was saying earlier, was the width will be just that Y value, because we noticed that they all hold that 2 for that one demonstration. And to find the height, what we'll do is we'll take the width and we'll subtract 1, and then we'll subtract the current X position we're at. Just to show you real quickly how that works, is we'll go here, and say we want to find where the C is supposed to go, either 1, 0, 1, or 2. We'll take width, which is 3, subtract 1. That accounts for the array index starting at 0. We'll get 2, and then since we're at 2 currently, we'll subtract 2. We'll get 0, and boom, we'll find that C is right here at 0. So that's how that works. And real quickly, go ahead and show you that it does in fact work. So I went ahead and rotated the Python guy, so there's that. And to go ahead and show you how I solved the shrink problem, so we start off by defining it, pass it an image, find the width and the height of that image, make a new picture with half the original size by dividing the width and height by 2. Then we'll go and show the original image, and then we'll iterate through it, skipping 2. So we'll go 0, 2, 4, 6, 8. We'll lose half the pixels in the new image, so it'll be a lower resolution. And then as we iterate through that by 2, we have to account for the smaller image, because we'll say if our width is 1,000, that means we're going to go to 0 to 1,000, but our new picture only has 500 space for that. So to account for that, we'll just divide it by 2. And we'll go ahead and show you what that looks like. So essentially it'll map the larger values from the original image to smaller values, corresponding smaller values of the new image. And to show you that, we'll go with the turtle, and there's the big turtle, there's the shrinked turtle, or the shrunk turtle, I don't know. So that's how I solved the two problems. They're pretty simple, pretty straightforward. I hope this video helps. If you guys had any struggles on it, maybe a little issue here or there, I took a little bit of time on drawing and figuring out this image. So yeah, it was a pretty fun problem overall. Hope everyone did well.